Our today's topic is shear force. Definition of shear force is the shear force at the cross section of a beam is defined as the algebraic sum of all the unbalanced vertical forces either left or right of the section. Consider one simply supported beam with uniformly distributed load. One side hinge and one side roller, simply supported beam. And what is shear force in this simply supported beam? The shear force at the cross section of a beam is defined as the algebraic sum of all the unbalanced vertical forces either left or right of the section. See, free body diagram of this simply supported beam. This A hinge support and B roller support. AY reaction, vertical reaction AY, horizontal reaction AX, and at roller vertical reaction BY. This XX cross section, see here, and up to this x cross section distance is x. Here shear force generate due to this external loading. Internal force, shear force is internal force. See, this is left side of this beam, left side of simply supported beam, and here right side there is a roller support, that means reaction by, and this uniformly distributed load. Total L, total length of beam is L, that means this right part is L minus X. Here vertical shear force generates to the right side V X, here Vx. See, due to external load there is internal force generation. This internal force is shear force. See here, left side of simply supported beam Vx generate, and here right side of simply supported beam there is shear force generate. The shear force at the cross section of a beam is defined as algebraic sum of all the unbalanced vertical forces either left or right of the section. So what is this definition? Meaning of this definition is, see, this shear force at the cross section of a beam is summation of, see, summation of this load is uniformly distributed load is W, summation of vertical forces, and to the left side, to the left side of simply supported, that means this beam. So here AY is vertical. Here vertical is positive and downward is negative. Vertical shear force is positive and downward force is downward reaction is negative and vertical reaction is positive. Here AY vertical, positive AY, W into X, and is acting on X by 2 from A. Therefore minus WX and minus Vx. So and this summation is 0 because this is statically determinate beam and equilibrium beam. Therefore 0 is equal to AY minus WX minus Vx, and Vx is equal to AY minus WX. So Vx is equal to AY minus WX. So this is shear force at the cross section of a beam in left side of a beam. The shear force at the cross section of a beam is defined as the algebraic sum of all the unbalanced vertical forces either left or right of the section. See here, right of the section, this right side of the beam, positive vertical Vx, vertical Vy minus W into X. So this is shear force. Shear force is summation of vertical reactions either left side of this cross section xx or summation of vertical reaction either right side of this cross section Fy. Fy left is sum of all vertical forces on the left of the section. Fy right is sum of all vertical forces on the right side of the section. And next is sign convention of shear force. An upward force, see, an upward force to the left of the section or downward force to the right of the section. See, this is, consider this is xx section. Upward force, sorry, xx. Consider this is section of a beam. Upward force to the left of the section or downward force to the right of the section will be considered as positive shear force. In another way, see here, left or right side, here vertical force, downward force is positive shear force. When the force is downward to the left side of the section and upward to the right side of the section will be considered as negative shear force. That means here which shear force we take, see, negative shear force we take here. Consider this positive shear force like clockwise. When the shear force is downward to the left side of a section and upward on the right side of a section, it's considered as negative shear force. That means x here downward and here upward. This is left side, this is the right side. This is negative shear force. Shear force term here, shear force at the cross section of a beam is defined as the algebraic sum of all the unbalanced vertical forces either left or right of the section. See word here. See word shear force at the cross section of a beam. This is cross section of a beam xx. Cut this cross section of a beam. That means at the cross section, this Vx left or Vx right. Shear force cross section of a beam is defined as algebraic sum of the unbalanced vertical forces either left or right. That means this shear force Vxl is at the cross section of a beam and is the algebraic sum of the this left side of the beam. See, I here, right here, algebraic sum, that means vertical forces, summation of vertical forces, and vertical force is positive and downward force is negative. This positive Ay minus W into X, this is uniformly distributed load W, and this uniformly distributed load W is acting on x distance. That means here this force is act like a Wx on x by 2 distance from A. That's why this positive Ay downward, Wx downward, that means minus Wx. This Vxl is downward, that means minus Vxl. And due to equilibrium, I I give here summation of Fy is equal to 0. This is statically determinate beam. Statically determinate, that means there are three reactions and three equilibrium equations. Equilibrium equations are summation of Fx is equal to 0, summation of Fy is equal to 0, and summation of moment at A is equal to 0. That's why I write here summation of Fy is equal to 0, that means is equal to Ay minus Wx minus Vxl, and here Vxl is Ay minus Wx. So summation of either summation of vertical forces on the left side or summation of vertical forces on the right side, and here sign convention of the shear force and upward force to the left of the section or downward force to the right of the section will be considered as positive shear force. Here this is section xx and this is downward force Vxl and upward force Vxs. In section xx, left side is downward and left side shear force is downward and right side shear force is upward. See here, left side is downward and right side is upward. That means we take here negative shear force. Consider, remember this is anti-clockwise. It means negative shear force. And when the force is downward to the left of the section or upward to the right of the section will be considered as negative shear force. So this is shear force term. Generally in design, beam design, slab design, footing design, in footing design we check shear, one-way shear, two-way shear. In slab, in beam design we also check shear. So shear force term is very important in structural design. Thank you very much.